Hi guys. Today I'm going to do something with the Euler's method, and this is problem 7 of chapter 11.2 of Euler's method. Here it's asking to consider a differential equation with y prime equals sine of x times sine of y. For A, it asks us to calculate the problem value using Euler's method. And Euler's method Euler's method is y equals y naught plus dy over dx times delta x. And in this case, we'll do this following in what's y equals sine of x of sine y. And in order to make it convenient, I'm going to make a table for problem 1 of A. So you have x, have y prime. It's asking me delta x equals to 0.1, and we're starting with 0, 2. So here I'll plug in 0, 2. And you plug in sine of 0, it's going to be 0, so y prime will be 0. And for this one, you see, since delta x equals to 0.1, we'll go with 0.1. And if you plug in this, y is going to be 2 plus 0 times 0.1, which is 0. And the rest you could do it in calculator, and it's asking you to do 3 steps. So let's do it. I'll just write down the number you plug if you can get when you plug into calculator. So you have 0.091, 0.2, 2.091, which is 2 plus 0.091 times 0.1. In this case, you have 0.179, 0.3, 2.027, which is 2.0091 plus 0.179 times 0.1. So this is how the slope will look like when it starts at the point of 0, 2. But that's not the interesting part. Let's do 2. So for part 2, it's asking to do the same thing, besides you start now at 0, pi. So this is going to be very interesting because you're going to start at 0, pi, and since sine of 0 is 0, your y prime will be 0. And if you keep going, you'll find something really interesting. You plug in 0.1, you have pi, because pi plus 0 times 0.1 is still pi. So which means since sine of pi is 0, you have 0. You plug in 0.2, you have pi, and you have 0. Notice that this pattern will repeat, because no matter how many times you go through, you always have a pi plus 0 times whatever number, which will equals to pi. And since sine of pi is equal to 0, so your y prime will constantly be 0. Isn't this interesting? And therefore, they ask immediately B, that use the slope field in figure 11.25 on page 59 to explain your solution in part A, number 2, which is this. But in this case, you don't have to use the slope field to explain what happened here. You can just think about it. First, let's just draw a single easy graph. So you have a y over here, and you have x over here. And if you have no idea what's y prime equals sine of x times sine of y look like, it's fine, because I haven't have any idea either. But if you start looking at y prime, you start at 0.pi. Let's see, this is 0.pi. That means no matter how much you move horizontally from that point, the y prime is always 0. What does y prime 0 means? It means that it's a horizontal line. So if you have on a point, start with point 0, pi, you're going to have a slope field that looks a lot like this. Which turns out really nicely is a horizontal line. And in fact, what the graph really looks like, is something that looks like this. Well, excuse my typo drawing, at least you got the idea. And really the more interesting thing is, in fact, it's not just you start at 0 pi that will get you a straight line. In fact, if you start at any point, for example, if you start at 0, 2 pi, 0, 3 pi, all the way to 0, n pi, it's all going to give you a straight line. Believe it or not, try it, but take my word for it. Thanks, everybody.